This is Unit 6, Data Communication and Computer Network Technologies. O-levels, we have done some of the content, but in A-levels, we are going to, discuss more details on data communication part. Now, when you say data communication, that means we are going to transfer message or data between two endpoints in two different locations, right? Now, to do that, you need to use different technologies. You have to have networks, right? So those are the things that basically we are going to focus on here. Right, now few things that we are going to discuss is today we will start looking at what communication is, and then we will look at different signals and their properties. So that's the start. Then once we finish that, we will also look at different medium, which we have already done, and then different topologies. We will start with discussing those, and then we will then look at how you may actually synchronize when it comes to communication, and then how do you make handle errors when you transmit something. And once you finish that, we will also look at that public switch telephone network we call PSTN to connect two remote devices. So that's what we discuss next. And then we will also look at modulation, demodulation. Remember, we talked about this earlier as well, converting analog to digital as well as digital signals to analog. And how do you use a modem and network devices such as hubs, switches, different topologies we will have. Then MAC protocol, this is something new that we are going to look. Any computer, we can uniquely identify any device in the network using MAC address, right? So how you are going to do this, so which we are going to discuss. And then how you are going to connect multiple networks together. Right now, so far we will look at like what is local area, how you create local area networks, but here we are going to discuss how multiple networks can be connect together. Then we will look at the IP addresses. We know that any machine can be uniquely recognized in a network using IP address, 4 numbers separated by dots. But then how do you create those IP addresses? How do you assign IP addresses in a network? So that is an interesting one, and we are going to detail discuss how we are going to do this. Then we will talk about what our protocols are. We have already learned Internet Protocol, IP, Transmission and Control Protocol, TCP, IP, then File Transfer Protocol, and so on. But we are going into details this time, right? What exactly mean by a protocol and how do you access it? And then some applications in the internet, right? So we know that when you are going to visit a web page, what exactly happens when you type address. Partly we have discussed this earlier as well. Then how do you identify the what we call the reference models, like when you talk about a network and the network architecture. So how do you describe different functionalities available in different levels? Now we will learn something called OSI model here, where it will describe different layers in the computer architecture, network architecture, and then their functionalities, right? And then we will look at the security aspects, especially when you're transmitting messages. uh, we need a way of protecting those messages, because somebody can, with the knowledge of the technology, they can steal your important data. So for example, when you're going to make a purchase on the internet, you may use credit cards, the credit card numbers and your account details could be in danger. So somebody can, extract or maybe steal your data. Now, to prevent this, we can use encryption, and how these encryption technologies work, we discuss in detail here. And then we will also look at what is ISP, internet service provider, and different technologies, how when you're connecting internet service provider, I mean, use of modems, ADSL, and so on. So that is another thing that we are going to look at, right? So with that one, we will finish the networking. So I think we briefly discuss exactly what we are going to do. And we spend some time on looking at the data communication technologies used, as well as networking technology. So both we are going to discuss in detail, right? Now let's start with the term, what do you mean by the communication? That's one of the things that we are going to look at it, because data communication. So I already told you data communication mean data transfer between 2 points, right? So that's exactly what we are going to do. Right. So let's start. Uh, First, we will write down what data communication means, right? We'll have a data communication. Important topic that we are going to discuss about the data communication. So we can simply say you transmit data between 2 points, or you can say two communicating devices. Now, when you want to communicate with two devices, you need some kind of a medium, right? Right. So you can write down data communication is the process of transmitting data between transmitting transmitting data between two or more devices using some transmission media. With the development of technologies, now we can transmit data from one place to another place within a couple of seconds, right? Now you can do this with a couple of fraction of a second, right? Like sending an email, for example, right? So with a couple of seconds, you can send email from here to US, right? Anywhere in the world. So this is possible. So what we are going to discuss is basically technologies used in communication network and what are the theories that we are going to discuss under this, right? Communication model. Let's look at the components. When you talk about communication model, which means what are the things involved in data communication, right? I told you like we are going to connect from one place to another, right? It could be, we use different devices to do this, but then, right, what are the parts of it? So we can have um, way of representing this one components. We will have senders, we will have receivers, and then we'll have message in between, right? So we will have senders and receivers. So one side we will have sender, or sometimes we call source. The other side, the receiving side, we have receiver. This is called sink, or sometimes we call destination. Now, in between what you have here, now what do you have here, right? So there are a few things that we want to, discuss, right? For example, um, we have senders, and then we have receivers, right? And then we have the messages in between. Right, so we'll have this. So we have transmission media, right? So we talk about later on, it could be wired system or it could be wireless, depending on what kind of a transmission happens in between, right? Then there'll be messages, right? There'll be messages or data, let me say message. And to communicate, you have to have a set of protocols. Right? We have to have set of protocols. Right? So that means we will have protocols. Right? So these are the components, basically, you can say, in a communication model. We can also look at destination here. Right. Okay, now let's write down details about this source. Right. We will have sender, source, put bullets here. Sender, source, we can say data preparation and generate. We can say generation and preparation. And preparation. So in the sender, what will happen? It will generate data, or it will prepare the data to be transmitted. To be transmitted. So that's the source, and then you have a transmission system. Or the medium, you can say. Actually, it will be the whole system that we should discuss, medium and protocols, everything together, right?
එතනත් මීඩියම් කියලා හදා නෙමෙයි සිස්ටම් කියලා හදා ගන්න ඕනේ.
මේවා පොතේ medium කියලා අපි කියන system කියලා කියන මම දැන් මෙතන යට transmission system කිව්ව හින්දා තමයි මම මෙතන වෙනස් කරේ. නමුත් transmission system කියන එක අපි හරියට ගත්තොත් ඒකේ තමයි ඔය ඔක්කොම ඉන්න ඕනේ. මේ සම්පූර්ණ system එකම තමයි මෙතනදී කතා කරන්නේ. particularly medium එක විතරක් නෙමෙයි. ඒක change කරාට කමන්නේ. ඔව් අපි change කරගමු නේද? ඒක medium කියලා කියන්න පුළුවන්. එහෙම වුණොත් අපි ඒ තනිකර medium එක ගැන විතරයි කියන්නේ. The system is responsible for transmitting data from source to destination. Then we will have receiver. We have receiver destination. Then protocol. So protocol means it's a set of rules. Like when you say data communication, there'll be two parties. How exactly this will happen, right? So first of all, when you want to send a message, you have to check whether there's a receiving party. And then before you sending, you have to check whether the receiver is ready. So likewise, protocol means a set of rules, like how exactly this transfer happens. So there are different, protocols that we are going to discuss later on with some details. But for the time being, we'll start with this. Then finally, the message. Right, the message. So it's the data sent from source to destination. So you see, now we discuss about the data communication. We said this data communication means you are sending or transmitting data from one place to another. And then when you look at how this communication happens, there are a few components are there. We have source, we have destination, we have the transmission system, and then we have messages as well as protocols. So you need these components for proper data communication. Now, if you ask me like how exactly what will happen when you say data transmit, this data transmission happens through what we call signals. right? So for that, we need to look at different types of signals available, right? So in this part, we are going to look at, different types of signals. So let's write down topic, signals and their properties. Signals and their properties. So when you say data transmission happens using what we call the signal, right? Using signals, we are going to, send details. So let's write down what a signal is. A signal is an electronic voltage or current which varies with time. It used to transfer data from one to another. So it could be both the voltage or the current. It will vary with the time. And this is exactly what we are going to use to convey data from one place to another. In telephone conversation, sound waves converted electronic signal and converted to electrical signal and transmitted to the destination. Then electronic signal or we can say wave, right? Electronic put wave, electronic wave and transmitted. The electronic wave then converted back to sound wave at the destination. Right. Now this is to discuss exactly how this transmission happens, right? How this transmission happens. So we need to know what these signals are. There are different types of signals we use. Let's start with analog signals. Analog signal. Right? So when you say analog signal, so it is a continuous waveform, we call it. Continue means it will vary. Let's say the two levels are between 0 and 1. So it's continuously changing from 0 to 1, like a sine wave. It's a continuous one. So don't take down this one. Let me show you exactly how the analog signal represent. So for analog, we can put it like this. It a continuous one. If the levels are, let's say this is 0 and this is 1, low voltage and high voltage, so it may contain all possible values between 0 and 1, right? All possible values. Right. So let's take down this. Don't draw. First write down and then we can draw. So in analog signals, we can say it's a continuous waveform. We can say analog signals are continuous waveform. Such as sound, light, and temperature. So these waveforms like sound and light and temperature, it will vary. Advantages. Advantages. Use less bandwidth. I will explain what bandwidth is. Than digital. Accuracy is high. Right, accuracy is high. Disadvantages. The cost is high. What do you mean by cost here is maybe when you want to create or record uh, analog sound, e.g. recording analog sound in a tape, the cost will be really high. Noise. Can cause distortion and signal loss. What do you mean by this? Noise means now when you say we are sending voice, someone's speaking, and other sounds other than that, we can say it's noise. So when you have noise with analog signals, it can change the signal, right? Distortion. So you will get, different, sound. So analog, I told you it's expensive, high cost is high. Error correction is difficult. If there are errors, no error correction in analog. We will discuss in digital, we can error correct. Right. So those are some of the details that I would like to discuss. Now, next one, I would like to discuss digital signals. Now, I told you this is continuous waveforms, that is analog, right? Then let's look at digital signal. Digital signals. Now, in digital signals, what you have is two levels, or like you have two discrete levels. Right? And the signal is uh, two discrete levels, let's say, and in mathematically we say 0 and 1. The values are only 0 and 1. This is exactly how we represent everything inside the computer. So in this particular case, so the digital signals, you have only two levels. When the voltage levels changes, like in this pattern, right? This pattern. So then we call it a digital signal. Right? We call digital signal between two values. So in analog, we said continuous waveform, right? So let's take down digital signals. Digital signals represent two discrete voltage, or it could be current levels. Yes, two levels. It represents let's say, uses only two values. Right? It uses only two values to represent something, e.g. 0 and 1. So this is exactly what we see, especially in digital signals and inside even in the computer. Right. Now, like in previous case, let's look at what are the advantages and disadvantages. So the bandwidth I told you, like we will discuss later on what exactly what exactly the bandwidths are. But you can take now, for example, the amount of data that you can transmit can be discussed or represent using the bandwidth amount of data. So that part I'll discuss. Right. So let's look at the advantages here. So the couple of advantages in digital signals. So first of all, it is inexpensive. Earlier it was expensive. Privacy reserved. I will explain. Data can be encrypted. For security, I told you, like, data can be encrypted, meaning like you can jumbled. Nobody can understand what this is. Error correction is possible. Errors can be corrected, right? Error corrections possible. Disadvantage, you need large bandwidth. Synchronization is difficult. If you want to happen exactly the same way something, right? So in digital signals, usually bit difficult. Right. Now that we have discussed, different signals that you will have, basically in data transmission, I told you it's analog as well as digital. So in analog, you have a continuous waveform, continuous values are used for the data transmission. In digital signals, you have two discrete levels like 0 and 1 is used. Right. Now let's move on to the next topic. Now that we have learned the two types, let's look at properties, right? So properties of signals. Let's write down properties of signals. Properties of signals. So when you talk about the properties, there are different qualities of signals we are using. We will talk about amplitude, then frequency, wavelength, and different phases, right? So we'll go one by one at a time. What do you mean by this, right? Now, amplitude is basically to say that the height of the wave. Remember, we talk about the waveform. It could be continuous, it could be, discrete, but the height, right? So let's start with the amplitude first, right? The four properties that we are going to use let's say we are going to look at amplitude. Amplitude, frequency, wavelength, and phase. So let me start with amplitude first. So amplitude. So if you have the waveform like this, so the height, right? I told you it should be the height. We can write down this is the height of the wave. Height of the wave. So we can simply say height of the wave. Right. Then let's take down frequency. So in frequency means the number of waveforms that can be used per some given some time, right? Number of waves. Now let's say this is a sine wave, so this is a sine wave. So this is 1, this is 2, and so on. So let's say we have 1 second. So this waveform right? There are 60 waves, and the second one we will have only 30 waves. So we can say this, the first one is a high frequent waveform. The second waveform is a low frequency, because the number of waveforms or number of waves within a 1 second is very limited here, right? So here low frequent, this is high frequent. You can draw only one, you don't have to draw both, right? We can say the number. The number of waves that pass a point in 1 second, we will measure it in hertz. Number of waves pass by 1 second. So 1 second, the first one 60. Right? Second one it's 30. So we can say the first one is high frequent, the second one is low frequent. Okay, next one, wavelength. Wavelength. The distance between adjacent crests measured in meters. So distance with the adjacent crests. So in the heads, for example, here, from this point to this point. So these are the same points in the waveform. So this is called known as wavelength. So you have one wavelength here. Similarly, if you go these 2 points, again, they are the similar points. The distance between these 2 points is called wavelength. Now, last one, we will have phase. Now, phase here means the starting point. So different signals start in different points. We call different phases are there, right? So that's exactly what we mean by the phases. So we can talk about something like phase difference. Right? So if you see the same point varies in two different signals, we call it two different phases, and we call phase difference. Right? So let me show you with an image. Now in this one, let me make it bit smaller and then remove unnecessary parts. Let's keep this, right? So two phases. Right? Two phases. So this is one signal, This is another one. So first of all, this one, the phase start with here, but in this case, its phase start with somewhere else. So there's a phase shift. So if you look at the same points in the two signals, and if you take the distance, we call phase difference, right? So the phase is actually a position in a point in time in a wave cycle, right? So for example, this one position, this is called phase, one place. So if there are multiple signals and then phases are different, we call a phase difference. So let's write down the phase is a position of a point in time, because this is varying, right, with the time. So this side you have a time. So with the time changes, this will increase and then you will decrease. So this happens in light wave, current wave, for example. It goes up and then comes down and then again the other side and then will come to zero. Right. So in a two waveforms, this could be known as the difference. So the speed at which the waveform travels in a medium, we call it a propagation speed, right? The speed which a waveform travels with a medium is called propagation speed. Propagation speed. So how fast this will travel? So usually this is equal to the wavelength multiplication of wavelength is equal to multiplication of frequency and the wavelength. So you don't need to remember this. But just to give you an how fast a waveform travels from one place to another place. Right. Now with that one, we will finish discussing the basics. Right. Then we are going to talk about more details on right. So let's look at this part. So with that one, we finished discussing the basic signal types. We discussed two types. And then we discussed the properties. Right now, we are going to discuss more details. Right. So we are going to discuss what do you mean by this latency, bandwidth, noise, attenuation, and distortion. How these affects signal transmission. So now to discuss this, right, we will discuss different medium used in data transmission. We know that we can use wired media like twisted pair, coaxial, and fiber optics. And also we can have free space unguided media. Then depend on what medium we use, we will have different values. The latencies, bandwidths, noise, attenuation, and also distortion. So this is exactly what we are going to discuss it here. Right. Okay. Now, one of the things is the wires that we will use, right? Or less wireless transmission. So in wired connections, we have different medium we have used: twisted pair, coaxial cable, fiber optics. So these are there, right? So these are there. So we have actually discussed this under communication. So different medium we can use in data transmission, right? We have guided media, and then we have, wired media, right? So these things that we have already discussed, right? So for example, I will again get back to this, what we have. So in guided transmission media, we use physical medium, right? So a physical medium is used. A physical medium is used to transmit data. So under that, we will have twisted pair cables, right? And under the twisted pair, now we will have, you know what, different bandwidths are there. So we have twisted pair cables. And there are two types I discuss: unshielded twisted pair and shielded twisted pair. So when you use a pair of copper wires, don't take down, right? I will give you time. So use a pair of copper wires, especially in here, with a plastic cover. So you will have a plastic cover here. And so why there's a cover? Usually to remove the effects of electrical effects, because when you have wires mixed together, so that happens, right? Then the cost is quite low and bandwidth is also low. And when you increase the size, the data transmission, so the data signal will lost, right? So the long distance could not travel with the twisted pairs. But then we can use UTP cables or shielded twisted pair, right? This is unshielded, right? UTP. UTP means copper cable, and then you can have shielded pairs, right? You can have a separate shield for this, which is you have high bandwidth. So if you look at the advantages of twisted pair, right, we can write about the twisted pair. Maybe you can take down up to this one: guided wire transmission media. A physical medium is used to transmit data. And then under that, the first one is twisted pair. We use a pair of copper wires with a plastic cover, right? Features are, right, low cost. Usually twisted pair cables are price is lower. Then bandwidth is also low. Bandwidth is also low. To travel long distances, repeaters are used. The idea is like when you have very large distance to travel, when you have very large cable, signal will distorted, like system signal will be lower. So which means you have to use a repeater if you want to, transfer long distances. So under that, yes, now you can write down unshielded twisted pair UTP cables. right? Under this, you can, if you need UTP cables, you can look at the Cat5 cable types. Cat5 cable. So there's a cable called Cat5. In Cat5, data transmission speed is about like 100 megabytes per second. Actually, it should, and the max length. So this is data transmission speed is about 100 megabits per second. And then if you take the distance, right? You can say 100 megabits per second, not megabytes, bits per second. And then max length of the cable, it will be 100 meters. The recent one is called Cat6 cables. Again, you don't have to remember this. Data transmission speed, they say up to 10 gigabits per second, 10 gigabits per second. Again, maximum amount of length for the cable is right. Now usage is right. So Cat5 cables usually use Ethernet, right? And Cat6 is gigabit Ethernet. If you need Cat1, early days, the telephone wires were Cat1. Let me type that one as well. You don't, again, not need to remember. Data transmission. This is very old cable, phone cables. The speeds were around like 1 megabits per second, 1 megabits per second. And there's no max length for this, right? E.g., we can say old telephone phone cables. So Cat5, this is used in Ethernet. What do you mean by Ethernet? Basically, you can have a LAN, local area network. So that is Ethernet connections, we call it. So use. But if you need the highest speed Ethernet, we call gigabit Ethernet, right? Then you use Cat6. So this is called gigabit Ethernet, right? So that's about the unshielded twisted pair. There are different categories, and then you will see that amount of data range bandwidths are different. Okay, so you can now take down up to this point under twisted pair. So the second, type we call shielded twisted pair. So you have an extra cover outside. And you have better transmission. Then we will have coaxial cables. And coaxial cables we used in TVs. So bandwidth is about 10 megabits per second. Now, features for coaxial. If you look at what are the features, noise successfully. Noise is medium. Then transmit data longer distances at higher speed. Right, coaxial cables we have seen it is used in TV antennas, especially this is an example we will take. But nowadays we will also have CCTVs for security. So features, as I told you, handles noise successfully, transmit data longer distance at high speed, right? Used for both analog and digital signals. Analog and digital signals. Right. So that's about the coaxial table. Now, finally, what we have fiber optics. Fiber optic cables. And it's especially in these cables, we will have light beam, right? You have a light beam. So we can say features. So high bandwidth. Right. So it's basically expensive. Fiber optics, usually we will put these cables underground, especially when you want to connect cities or countries. what we use is fiber optic cables, and which is use a light. So that's why we call fiber optic. So you have a high bandwidth, but it's expensive. Right. I think we will stop for today here.